This is Sharma solution class 12 chapter 3 binary operation exercise is 3.4. Question number 1. Let star be a binary operation on Z defined by, how it is defined? It is defined on Z integers, defined by A star B equals A plus B minus 4 for all A and B which are belonging to Z. So this kind of question we have already done because there are 3 parts which is being asked here. The first is whether this star is commutative or associative or not. This is the first part. What is commutative? A star B, whether it is equal to B star A, that we have to find out. So this is basically A plus B minus 4. Here we have B plus A minus 4. You can just replace the position of A and B. You get A plus B minus 4 as this here, A plus B minus 4. So they both are equal. So star is commutative on Z. In associative, what does it mean? It means whether A star B star C equals A star B star C when AB is done first and BC is done first. A star B is simply A plus B minus 4 and then we'll do it with C. Okay, C. Here we'll have A star. This will be B plus C minus 4. B plus C minus 4. Now these two. So A plus B minus 4, that is A plus B minus 4. Then we have, this is the first term. Then you add the second term. Then you subtract 4. Similarly here, the first term add with the second term. A plus B plus C minus 4. And then we have a negative 4. Minus 4. Okay. So A plus B plus C is there. Minus 4 is minus 8. Here also A plus B plus C minus 8. What do you get? They both are same. So star is associative on Z. Now we'll go to the identity element and then the invertible element. But in order to find the inversion or inverse, we need to find out the identity element. What is an identity element? An identity element, that is, you take any element from this set Z. When you multiply it with the identity element, this identity element should also belong to that set Z. You should get the same value back again. So A star B equals A plus B minus 4. When we do A star C, A star E, what do you get? A plus E minus 4. And this has to be equal to A. So E will be equal to 4. So the identity element is 4 with respect to star. Now we have found the identity element. Find the invertible elements in Z. So we have to find out the inverse now. So Z will be equal to, see, A you take, B you take from here. So A star B and B star A, whichever you do, you need to get E back. Okay, A star B is A plus B minus 4. So you should get E. E we already know. We just found out. It is 4. So take it over here. A plus B will be equal to negative 4 I am taking here. So it will be 8. But what I am trying to say here is B is the inverse. When you multiply A with A's inverse, you should get the identity element. So B is the inverse. Basically, we have to find out what is B. So in this expression, we are interested in finding B. A plus B minus 4, you can take this minus 4 here. You get A plus B equals negative 8 plus 8 and B equals 8 minus A. 8 minus A is actually the inverse of A. Okay, which is belonging to Z. Now question number 2. This is CBSE 2010 question. So Q0 is what? Let star be a binary operation Q0. Q0 is set of non-zero rational numbers. That is P by P Q form with no zeros. Defined by A star B equals 3AB by 5 for all A and B belonging to Q0. A star B equals B star A. For that we will go for commutative. So I am taking 3AB by 5 because in the book it is 3AB by 5, but even AB by 5 also can give C. A star B is 3AB by 5, B A is 3AB by 5. They are associative because they are equal. And coming to, they are commutative, sorry. Then coming to associative, A star B star C. First we'll do this one. That we will get 3AB by 5. Star C, we'll get, let us do BC first. So BC 3BC by 5. A is already there. But you get 3ABC by 5 by 5. Here also A 3BC by 5 by 5. What do you get? 3ABC by 25. Here also you get 3ABC by 25. So this 3ABC by 25, 3ABC by 25. Here you see it is AB by 5. So in certain edition it is AB by 5. But since this in CBSE 2010, it has come as 3AB by 5. So I am doing it 3AB by 5. Right? If it is AB by 5, it will be ABC by 25. There will be no 3 here. So in both the cases, it is associative because both the left hand side and right hand side, they are equal. So CBSE 2010. Okay. Next is find the identity element if it exists. So how do we find the identity element? We'll find it for AB by 5 and 3AB by 5. Identity element is when you multiply any element taken from the set with this identity element, that element should come back. A star B equals A. So A star B is what? 3AB by 5. So I'll do it for AB by 5 also. So A star B, in this we have to use the B as E. So 3AE by 5. And this size should be equal to A. A cancels, E will be 5 by 3. If you are just taking this AB by 5, it will be only 5. So you can take E as 5 or 5 by 3 depending upon whether it is AB by 5 or 3AB by 5. Right? Okay. Now we have question number 3. Let star be a binary operation on Q minus 1. So rational number without a negative 1. You cannot take negative 1. Negative 1 is not possible. That is when you take A and B and the result, it should not be negative 1. Defined by A star B equals A plus B plus AB for all A and B belonging to Q minus of minus 1. Then first is commutative and associative, then identity, then we have inverse. Okay. Let us start with the commutative. Since we have already done this kind of question, okay. In the exercise 3.2, we have done this kind of question multiple times. In the 3.2, you can just revisit how we solve it. I will directly come to the identity part and then the inverse part, right? Okay. Identity element is A star E equals A. So A star B is what? A star B is A plus B plus AB. So A star will be A plus E plus AE. This equals A. A gets cancelled. You have E plus AE as 0. So E plus AE, you can take E common. E is 1 plus A equals 0. So either basically there are two values. So it can be either E equals 0 or 1 plus A equals 0. So 1 plus A equals 0 means A equals minus 1. But since Q minus 1 is given, that is you cannot have a as minus 1. So E has to be 0. This is the identity element. Now when we got the identity element, let us see the inverse. So in order to get the inverse, we know that when we multiply a value with its inverse, identity element should come back. So you are taking A from here and you are taking B from also here. They cannot be equal to negative 1. And when we operate them, we should get E. And since we just got E as 0, so we directly replace E with a 0. Okay. So A is star B is given by what? A plus B plus AB. So A plus B plus AB, this is equal to E, and E is equal to 0. So A plus B plus AB. Now take, and what we have to find out? We have to find out B, because B is the inverse. When you multiply A with the inverse, you get 0, that is E. So B we have to find out. In this expression, take B on left and whatever is coming, put it on the right. So B plus AB equals negative A. Take B common, 1 plus A equals negative A. B equals negative A by 1 plus A. This B is actually negative A by 1 plus A is the inverse. I hope you got the idea. Question number 4. Let A, this is from R0 to R, where R0 denote the set of all non-zero real numbers. A binary operation O is defined on A like this. I'll just show you how it is defined. It is defined as AB when operated with CD, you should get AC into C, comma BC plus D for all A, B and C, D belonging to, there is AB also belonging to R0 across R and CD also belonging to R0 across R. So whether it is commutative or not, whether it is associative or not. So when we operate AB with CD, if we operate CD with AB, the same should come. So AB, CD is already given. Let us do it with CD and AB. So what is happening? C should multiply with A. Next is B into C plus D. So here in this case what we get? D into A plus B. Now you see they both are not equal. They both don't seem to be equal. AC is okay. The second part is not equal. So this is not commutative. Please remember it is not commutative. Let us check for the associative now. Associative is what? A, B, C, D, but we need third term also in associative. So I'll just clear it. We'll deal with A, B, C, D and EF. That is, when A, B operate with C, D, what do you get? A, B and C, D. This is already given in the question. Huh? Okay. So you get AC, that is first two you multiply, then you multiply second with the first one and add the third one. So AB will operate it with CD and then we'll operate it with EF. I'm taking EF. Next term will be of course EF. So first we'll operate this one and this is already given. AC and BC plus D. So AC and BC plus D and this will operate with EF. So AC multiplied by E, ACE will be the first term. Then BC plus D multiplied with E, BC plus D multiplied by E, and then you add F here, right? So ACE, you have BCE plus DE plus F, right? Okay. Now we'll do the same thing. First taking CD and EF, we'll operate this one. So let me just write it because we are going to operate CD and EF first, then we'll operate it with AB. So let me write it again. AB operated with CD operated with EF. So CD and EF first we'll do. Okay. So CE, this will be CE. Then we have DE and then you add F. Okay. AB is also there. So A multiplied by CE, then B multiplied by CE, and then you add DE plus F. BCE plus DE plus F. Okay. Now what do you see here? This term is equal to this term. This is equal, and this is equal. So they both are equal. It is not commutative, but it is associative. It is associative. The next part is we have to find out the identity element. How to do the identity element here? Identity element is when we have some certain A, we multiply or operate it with E, you should get A back. A is what? We have AB. Operate it with E. Now E cannot be written like this. It is a pair. A, B, C, D, E, F, they are pair. So we have to write E as two values. I am just taking E, for example, XY. So when we operate AB with XY, we should get A back. What is A? This is also an ordered pair. So AX and then BX plus Y, this should be equal to A. What is this A? A comma B. I am writing A as A comma B. So AX equals A. I am just equating AX with A and BX plus Y equals B. From here you get X equals A by A, that is 1. You get X as 1. And then from here, I'm writing X as 1. So B plus Y equals B. Y is equal to B minus B, that is 0. So this X and Y, that is the identity element. So X and Y we have taken as the identity element. In place of X I am writing 1. In place of Y I am writing 0. So 1, 0 is the identity element in A with respect to this operation. The third part, we have to find out the inverse. In order to find out the inverse, if we have A and B, when we operate them, we should get E. But A and B we cannot take. Because A and B, I can take as A and B. In B, we can take CD. There is another way also here. But let us go with the way we understood just now. So AB operated with CD, you should get E. And what is E? 1, 0. This is the identity element. So equate this with 1, 0. Right. So AC, then we have BC plus D. BC plus D. This equals 1, 0. So AC equals 1. Then we have BC plus D equals 0. What do you get here? C equals 1 by A. Now this C equals 1 by A, just please remember we have to find C comma D because that is the inverse. So here put C as 1 by A. So B into 1 by A plus D equals 0. And this D will be equal to negative B by A. So C is 1 by A, D is minus B by A. 1 by A negative B by A. And that is your C comma D, which is your inverse. This question we will take in the next discussion. Till then, thank you so much. Take care of yourself.